Alrighty, this is a very important topic and one that you're really going to need to make sure that you grasp, and it's going to continue to come back many, many times. And this is slope. This is in the Big Ideas book, section 5.5. These are the notes that I'm going to cover. Alrighty. So if we look at this first one, okay, we want to find the slope of the line. This information is extremely important and it'll stay forever, so you just need to memorize it. So to find slope, you're going to eventually find that this is going to equal m when you get to certain equations. We're not there yet, but I want to tell you now that slope is m. Slope equals the rise over the run. So what that means is rise is the up and down. So if we start at this 0, 0, we can see that this rose 1, 2, 3, 4. It went up 4, okay? That is also the change in your y value. So the change in our y value, we went up 4. We started here, we went up 4. So our change in the y was 4. Now, it's rise over run, so run is this way. And so from this point over, we ran 1, 2. Okay, so, and that is the change in our x. And we're going to put the 2 underneath. Okay, now, we're going to reduce this. 4 divided by 2 is 2, but because it is slope and it is always rise over run, we're going to leave this as 2 over 1. We're always going to leave it as a fraction. If it's not a fraction, just add your 1. Okay, so we always start at the 1 point and then go to the other. To do that, we go rise over run. Okay. All right, so over here on the next one, we have 2 points that we've been given. Okay, we again want to find the slope, so slope equals rise over run, which is our change in y over our change in x. Okay, so we're going to look for the up and down movement first. So starting at this point, we're going to go up 1, 2, 3, 4, and 5. So we've risen 5. Okay, so that means our rise is 5. Our run, or our change in x, goes this way. So now we're going to go 1, 2, 3, and 4. And we're going to put that 5 over 4. And we're going to leave our slope as that because we always want to be able to say the rise is 5, the run is 4. So unlike other times when we would turn this improper fraction into a mixed number, we're just going to leave this one. All right, so let's look at letter C. So we're going to find our slope, which is m. That is our rise over our run. So we're going to start from our point to the far left, and we're going to rise 1, 2, and 3. So our rise is 3. Our change in the y value, it went from a 0 to a 3. You can see that. So it went up 1, 2, 3. Now we are going to run. So we're going to go 1, 2, 3, and 4. So we ran 4. So our slope is 3/4. We have a change in our y of 3 and a change in our x of 4. Alrighty, so look at this one. I would suggest you push pause for a minute and try this on your own. All right, so on this one, we're again looking for our slope. So we're going to look at the change in our y over the change in our x. So starting from this point, we're going to rise 1, 2, 3 points. And then we're going to run. And that means we're going to go 1, 2, 3. So So this one is 3 over 3. We do need to reduce that. And when we reduce that, we can actually get 1 over 1. We are going to keep 1 in the numerator and 1 in the denominator because we have to say this is the rise, 1, and this is the run, 1. You can see if you look here, if we were just to rise 1 and run 1, we would be able to put a second point on our graph. And if we did it again, rise 1, run 1, we could put a third point on our graph. And if we were to do it again, rise 1, run 1, we could do another point on our graph. So even though this graph with the points given showed us 3 over 3, when we simplify it, we can see that we could have put a point every single time. Right? This is forming a line. This is why it is known as a linear equation. Alrighty? And we can see this linear equation goes right through the 0, 0. Alrighty, we now have a word problem. I know some of you really enjoy those. This says, by law, the maximum slope of a wheelchair ramp is 1/12. So that's the maximum. If a ramp is designed that is 4 foot high and has a horizontal length of 50 feet, does this ramp meet the law? So what we're going to do is we're going to show our ramp is 4 feet high, so that would be your Y value. And our X value is, it has a horizontal length of 50 feet. Okay, what they're asking us to do is we're being asked to find the slope of this. So the slope, which is what the wheelchair would go down, will be our M. So our M equals our rise over run, so our 4 over our 50. Okay. Now, when we do this, we need to reduce. So this is, we could divide both by 2 because they're even, and we get 2 over 25. Now, we need to compare this to 1/12 to see if we are still good by the law. So the maximum slope is 1/12. So as long as this is smaller than 1/12, we will be okay. Alrighty. So if I multiply, so I need a common denominator. And it looks like it's actually just going to be 25 times 12. So 25 times 12 gives me 300. So I'm going to use a denominator of 300. Okay. 12 times 25 gives me 300. And 1 times 25 is going to be 25. 25 times 12 will give me 300. So 2 times 12 is 24. Is this still less than the maximum? And yes, it actually is. So, does this ramp meet the law? Yes. Because our slope is, and I ran out of room, 2 over 25, which is less than the 1/12. Okay. Now, there are a few words that we need to know with slope. So the slope is the rate of change between any 2 points. Okay, so in all these examples, we had 2 points. It is the rate of change. Change because it's change of y over change of x. So the slope is the rate of change between any 2 points on a line. It doesn't work if they are on a circle. It doesn't work if they're on an arc. It only works when they are on a line. To find the slope of a line, find the ratio of the change in y which is our vertical change, that's the up and down, to the change in x, which is your horizontal change. Okay? So slope, we're going to also put above the slope m, because slope always equals m in the equation. Alrighty? Write down any questions you want to ask, and I will see you in class.